Good morning, class. My name is Mr. Sanford, and welcome to physics. Does anyone know what force is? No, not Star Wars force. Good guess, though. I like Star Wars. Does anyone know what motion is? No, I've heard that a lot from some of my other kids, but not that kind of motion. Today, we're going to talk about Newton's first law, and we're going to begin with a short demonstration. We just have a shoebox and a pen. Do you see how the pen rolls when I push it, but it stops even when I'm not touching it? Why is that? Newton's first law. Today, we're going to learn a few things about it, and then you're going to be able to recognize it in your regular everyday life outside of here. My goal for you all today is to be able to differentiate inertia, various elements of Newton's first law, see how it impacts your everyday life, and you will also get a better understanding of the importance of wearing a seatbelt when you're in a car. Let's start off by defining what Newton's first law is. Newton's first law tells us that an object at rest stays at rest, and an object at motion stays in motion unless acted upon by an outside force. Inertia is an object's resistance to change in its motion. So what that means is the resistance the object has, which means the ability it has to not move or move, whether something is forcing it, attempting to force it to move, or there is no force being put on the object, so it gets to stay. In the example just shown, with this ball being rolled on the floor, it rolled for a little while and then eventually it slowed, and it stopped. The reason why it stopped is because the friction from the floor was inputting on the ball and it was slowing it to come to a stop. If we were to throw this ball in space, what would happen? Yes, it would just go on forever and ever and ever and ever. Okay, after the two demonstrations that we have, you should be starting to get a little bit of a better understanding of Newton's first law and how it impacts your everyday life. We do have one more example that we're going to show in a little bit. I just want to talk about how Newton's first law affects us in cars, because a lot of the times, you guys are young, you're listening to your music, and you're riding the cars, you don't think seatbelts are as important as they may be. Newton's first law is the key in why they're very important, because if your car is going at, let's say, 60 miles an hour and you're traveling inside it, how fast do you think you are going? Good, yes, 60 miles an hour. Now, let's say you abruptly brake and the car goes from going 60 miles an hour to 10-20 miles an hour, but you're still in the car. Based on everything that we've learned so far, how fast are you going? Good, still 60 miles an hour. So that is what the seatbelt is for. The seatbelt stops you from continuing to go forward when the car comes to a complete stop. I know this is going to be a little bit graphic, but if you weren't to wear a seatbelt, you could keep going until something stops you. Whether it's through the windshield, whether it's if you get stopped by an airbag, whatever it is, you want the extra protection to keep you safe, because you never know what can happen in a situation like that. All right, guys, for this last demonstration, all we need is a cup, a piece of paper. I'm using an envelope because it was just right there, and a coin or anything like light, little dents. Okay? You're gonna take the cup first. You're gonna put the cup down, and then you're gonna take the envelope or a piece of paper, whatever you have, and you're just gonna put the piece of paper on top of the cup. You're gonna cover the cup completely. Then you're gonna take your coin. You're gonna put your coin right on top of that cup, on top of the envelope. All right? Now it's really easy. You just want to take the piece of paper and you want to pull it as fast as you can. Now you're gonna see that the cup, the coin, has now fallen inside the cup. Now, hold on. I know that was a little bit hard to see for you guys, so let me get it set up and let's try it again one more time. Let's see if I can get you guys a little bit of a better angle. Okay. So you got the coin right here, piece of paper, cup. I'm just holding the cup to make sure that when I do pull it, that the cup doesn't fall over, because there's nothing inside of the cup right now. It's empty. See? The coin is demonstrating inertia. The coin wanted to stay on top of this piece of paper, but it fell down. Why? Good. Gravity, yes. All right, I have another question. What would happen if I pulled the piece of paper a little bit faster? Good, yes, it would stay on the coin would stay on the piece of paper. I'm sorry, guys. Jumbling my thoughts a little bit. All right, now I just have a couple questions for you guys. First, what made the cup fall? Sorry guys, got my words all jumbled up. What made the coin fall into the cup when I pulled the piece of paper? What was the force after the paper was gone that pulled the coin into the cup? Good. Gravity. What would happen if I pulled the paper slower? Good. The coin would stay on the paper. Why didn't the coin move with the paper? Amazing. Inertia. Yes, that's exactly why. The coin wanted to stay at rest. Good. All right, guys, now we're gonna do a little bit of an example to show a little bit of what we were just talking about. Now we have this ball, and we're going to take it and put it on the floor here. Well, you can't see it, but the ball has just stopped, and it stopped right here. Okay, I'm gonna do that one more time. Ball rolls, still rolling around a little bit. then it comes to a stop. This is another example of Newton's law.